Okay, so first question I'm hearing is number 9.
Yes.
Number 9 was an issue. Okay. So for number 9, it gave you 2 different species. The first one it gave you was HClO4, and then the second one it gave you was HNO3, which both of them you should have recognized were what? Strong acids. Okay. And then remind me what it asked you. It asked you to. It told you that it's 2.50 molar. Then it asked you to give the major species in the solution, and then
Calculate the pH.
find the pH. Okay? Alright, so first thing, major species in the solution. You should have recognized that HClO4 and HNO3 are both what? Strong acids. We recognize that they are both strong acids. So therefore, we know when we put these in solution, what is going to happen to them?
Dissociate.
They're going to completely dissociate. So it's going to dissociate into H positive and ClO4 negative. And then this one would dissociate into H positive and NO3 negative. So what are the major species in the solution in A? H positive and ClO4 negative. Okay. Why is this not a major species, HClO4?
It's not dissociated.
Because what did it do in solution? Dissociated. So do I have any of this left? No. So it's not in solution. These are my 2 ions that are in solution. Same thing here. So I know that these are my 2 ions that are in solution. You see that?
So basically, if it's a strong acid, then it's going to be the products that are the major.
Yes. If it is a strong acid, your products are your major species.
Where is that exactly in the notes?
Yeah, I couldn't
Yeah, I
find
was
that.
trying to.
It was
I don't know why.
number exercise 9, where I showed you how it dissociates, and that's how we get the concentration of H positive. But there was no question in the notes that said what are the major species. Yeah, no, don't stress about that. No, you didn't miss anything, Hope.
Okay, making sure.
All right. So then the second thing it asked you, we did major species. Now it wanted you to find the pH. Okay, so that goes back to exercise 9. If they give me the concentration of the strong acid, then that means they also gave me the what? Concentration of
Hydrogen.
hydrogen. If I know the concentration of hydrogen, can I find the pH? Yes. pH is equal to opposite the log of my concentration of H positive. So in this case, it would be opposite the log of 0.250. How many sig figs is this? 3. So how many decimal places do I need? 3. So you should have gotten 0.602 for the pH. And since it's the same concentration for this one, that means it's the what? Same pH.
What if we changed it to scientific notation and then 6.01? Wouldn't that still be 3 decimal places?
Yeah.
So is that okay?
That's fine. If you did it in scientific notation, as long as you make sure you still have 3 decimal places, you're fine. Okay, so 6.02 times 10 to the negative 1 would not be correct. Does that make sense? Because that's still only 2 decimal places.
So if you're going from pH to
Okay.
getting you the
Yeah,
concentration.
let's.
So-
do some things.
So you're saying, all right, so let's say that I gave you, like, let's do number 8A. Okay, so for 8A, it told you that the pH is equal to what? 15.3. Okay, and then it asks you to find the concentration of H positive, right? And OH negative? Okay. So it asks you to find the concentration of H positive and the concentration of OH negative. So, since it gave me the pH, I know I can work backwards and say the concentration of H positive is equal to, you can write out the analog stuff if you want to, but really it's just 10 raised to the negative pH, right? So the negative pH of this would be negative 15.3, right? So if I put that in the calculator,
What if I rounded like to 100?
alright, so I raise it to the negative 15.3 and I get 5.01 times 10 to the negative 16th, right? Okay, but how do I know what sig figs I'm working with here? How many decimal places did it give me in my pH? 1. So that means how many sig figs does my answer need to be in? 1. So the correct answer here would have been 5 times 10 to the negative 16.
If you're going from concentration to pH, it'd be opposite. How many sig figs? How
Yes.
many decimal places?
So if I was given the concentration of hydrogen and I had to go to pH, I would say 1 significant figure, 1 decimal place. Yes.
Okay, when, I know like this is gonna sound dumb, but like significant figures, can you go over the rules for zeros? Because the zeros confused me.
Rules for zeros? Absolutely. All right, so if I have, let me see, 0.010, okay, and I ask you how many sig figs are in this number? Okay, the answer is 2. You are correct. Here's how you can do it, okay? What is the number that I absolutely know is significant in this number? 1, right? I know 1 is a significant figure. So I draw a box around 1, okay? And I say any 0 to the right of this counts. It is significant. Any 0 to the left of this does not count. Remember in pre-AP we always said left zeros are losers, okay? And remember this only works if there's a what? Decimal. If there's a decimal you can use this rule, okay? So I know this is 2 sig figs, okay? Because the 1 automatically counts. Any number that's not 0 counts. And then this 0 counts because it's to the right.
So it's like 0.05, it just have 1.
Yes. So if it was 0.05, that would just be 1 significant figure. Okay? Because both of these zeros are to the left. Left is losers.
So if you had like 200, that would still only be 1
Okay.
significant figure.
Yes. And if I had the number 200, no decimal, okay, then it's still only 1 significant figure. Okay?
Like what if it was like, you know, like 205, like the one in the middle?
So 205,
Yes.
that's 3 significant figures. If a 0 is between 2 numbers that are significant, then the 0 counts. Does that help?
Yes, sir.
Yes, sir.
Putting anti-log in your calculator.
What? Do you have, what do you have?
That.
This? Okay. Let me stop it. I don't like being on the camera, but I'll do it. Let's put it up here first, you know. My bad. My bad, Hopeful, my bad. Alright, if you have this calculator right here, alright, and you're putting your anti-log in, I'm going to hold it up for you in just a second, Mark, but they may have the same question. Alright, so put in your number, which in this case, in 8A that we were working, the pH was 15.3. So I'm going to put in 15.3, and I already know I'm going to have to make that 15.3 what? Negative. So I put in negative 15.3. Do you see that log button? Right. I can't do this backwards. I'm not that coordinated. All right. The log button right there. Do you see above the log button where it says 10 to the x? Okay. That's your anti-log button. So hit second log. So when you hit second log, did you get it? The 5 times. That's how you put it in your calculator.
Okay, can you do the anti-log thing? Like, if the pH given is already negative, do you keep it negative, or do you do the opposite of that?
You do the opposite of that. So if I was given a negative pH, then I would make the pH positive when I did the anti-log. All right. Any more questions? Okay, let's take our quiz. Pass up your homework.